Okay, today we're going to look at piecewise functions. You may or may not have worked with these before. We're still in section 2.2, and piecewise functions are simply functions that are in different discrete pieces. So what we have here is a function that's in two pieces, and these are the domains. So the domains are x is less than or equal to 2 and x is greater than 2. So I'm going to graph that top function. We'll do negative 2x minus 1. We're going to graph that in red. And that's just a linear function with a slope of negative 2 and a y-intercept of negative 1. So if I take my red line, oh, that's the green line, and drag it over, I will try to have a slope of negative 2, something like that. So if I were to draw that function without the piecewise function, it would look like that. But that function says to only draw it when x is less than or equal to 2. So what I'm going to do is take this line and I'm going to back it up until it's right about there, because that is x equals 2. So if you, I want that in red still. So that would be that piece drawn from x is less than or equal to 2. And what I'm talking about when I say x is less than or equal to 2, we're really talking about this line. So that top function, negative 2x minus 1, won't cross that dashed line. So if we go to the next part, which is negative x plus 4, we're going to do the same thing. So normally that function would go through 4, we're talking about that one, and it would have a slope of negative 1. So if I take my green line over here and do my best to make that a slope of 1, looks like that. So if there were no piecewise function there, that green line would be fine like that. But that says it's defined only when x is greater than 2. So we're going to back that up to our line there. We'll arrow on it. And in that case, that's what the whole piecewise function would look like. I'm going to get rid of this dashed line because that's not necessary. And in green, if you look at x is greater than 2, that does not have an equal sign, so we have to have an open circle. And if we look at the top function, x is less than or equal to 2, we need this solid filled circle there. So that would be one example of a piecewise function. So for this one, it looks a little more complicated. The good thing is most of the parts are easy to graph. So I will choose, let's do this one in red. We'll do that middle one in blue, and we'll do this last one in green. Okay. All right, so let's graph the green one. It doesn't really matter which one you use first anyway. So we're going to do negative 2x plus 4. So again, that would go through 4, and I'm drawing the whole thing just to kind of anchor my line. So it goes through 4 and has a slope of negative 2. So I have my intercept of 4. I go over, do my best to create this slope. And so that line would look like that, but this is a piecewise, so we're only drawing it for x is greater than or equal to 2. So I'm going to grab it, and I will draw it only for the part that's 2 or greater. Okay, so we're going to have 3 distinct sections. So in a dashed black line, how about this? I'll separate my domains. So I have when x is greater than or equal to 2. I have the numbers between negative 2 and 2 for that middle function, middle part of the function. Then we have everything below it. So we're going to have 3 distinct pieces here. Okay. So for the blue line, what we're going to do is, let's see where that one is. That's between -2 and 2, and the function is easy. It's x minus 2, so a slope of 1, intercept of -2. So I'm going to go here, put that dot on -2, and that's a positive slope in this case, so we're going to go that direction. And I'm just going to back that up so that it does not cross my domain lines. And then let's go to the red function. So in that case, it's -4. So this one always gets everybody. That's just a horizontal line that goes through y equals -4. So I'll grab a line. Actually, let's grab one of these horizontals. So all this one does is go through the value -4, and we only draw that from -2 and below. Okay. Oh, no, that's not what I wanted. And what I'm going to do is erase these black lines because those aren't really supposed to be there. And then let's just deal with all of the equal signs. So if I look at the three pieces, x is less than or equal to -2, well, that has an equal. So that means this point here would be included for the red line, not included for the blue line. And if I look at x is greater than or equal to 2, or this green function, that one includes 2, so we'd have a point here that is included in the green but not in the blue. So that would be how to graph that piecewise function. Okay, for a third example, this one is asking us to create the function. So if you look at it, I'm going to draw these divisions in red. So you have these three distinct domains. And the only reason I'm drawing these vertical lines is so that it illustrates what I'm usually pointing at in person. So we have three distinct functions. So I know that this is going to be in three parts. Okay, and when I do these, I like to work with the, let's scoot this up. I like to work with the domains first. So the function the furthest to the left has a domain of less than 4. The function in the middle goes from -4 to 4. And then -4 to 2. And then the third part goes from 2 and above. And you'll notice for that one, I didn't have any equal signs, and that's because we have open circles. Okay, so now all we have to do is figure out what they are. So I will circle the parts I'm talking about. So this section is what I'm going to look at. So that's a horizontal line, just like in the previous example. So whatever that would go through on the y-axis would be the equation. So this would go through 2. So that part represents 2. Y equals 2. The middle part has a slope of -1. So I know that's going to be negative x. So now we're talking about this part. That's going to be negative x, and then its intercept is -2. So it would be -2. If I erase, I'm going to erase that. That last line, that one has a slope of 1, positive 1 this time. And if you were to continue to trace it, it would go through -6. Okay. So if I clean all this up and just get rid of all this stuff, I'm not supposed to have that on that graph, then that function would have those three parts with those three equations and domains.